In this short video, I want to look at a few summation formulas using sigma notation, but you don't really have to use a sigma notation. It's just a convenient way to write this. Let's say I have the sum as k goes from 1 to n. I'm not going to tell you what n is. It's just a number, 5, 10, 15, who cares, of the number 1. All this says is we go through this from k goes from 1 to 2, 3, 4, 5, up to n. And each time you're adding up the number 1. So when k equals 1, we start with 1. And when k equals 2, we still add 1. When k equals 3, we still add 1. And we do this, we go through this cycle. This says go through this cycle n times. So we have n ones. Well, if I take 1 and add it to itself n times, this isn't hard to figure out, I get n. You take 1 and add it to itself n times, you get n. That shouldn't be hard to figure out. If I take 1 and add it to itself 10 times, I get 10. If I take 1 and add it to itself 12 times, I get 12. Let's take a look at another formula. K goes from, I'm going to show you a very specific one to start with. Let's go from k equals 1 to 100, and this time I'm going to add up k. So this is the number 1 plus 2 plus 3. This time k, what I have over here is k. I'm not adding up ones, I'm just adding up whatever k is. 1 plus 2 plus 3 plus 4 plus 5 plus all the way up to 97, 98, 99, 100. Now it's not immediately obvious what that is. We could just go ahead and type that all into our calculator. But there's a famous story about this, that when the mathematician Gauss was a 6-year-old schoolboy, that the teacher gave the class this problem to keep them quiet for a while, and Gauss answered almost immediately. Now, we don't know exactly what Gauss did to compute this, but there are a number of ways that you can compute this very quickly. Let's group the numbers like this. We'll group the 1 and the 100. We'll just add those up. So 1 plus 100, that gives you a 101. 1 plus 100 is 101. Now we can group the 2 and the 99. 2 plus 99 is, again, 101. And the 3 and the 98, 3 plus 98 is 101, and so on. How many pairs of numbers are there like that? Well, there are 50. And each one adds up to 101. 50 and 51 get paired. So 50 times 101 is 5,050. By using that kind of reasoning, you can come up with a formula. So this is the first formula I want you to take a look at. You can work out a formula where you have the sum of the numbers from 1 to n. Here n was 100, but n could be anything. If you add up the sum of the numbers from 1 to n, 1 plus 2 plus 3 plus all the way up to n. Here's the last number, here's the second last number. This works out to n times n plus 1 over 2. So if we plugged in n equals 100, you have 100 times 101 divided by 2, 5,050. I want to take a look at one more. This is the sum of the first n perfect squares. 1, let me write it like this, 1 squared plus 2 squared plus 3 squared, all the way up to n squared. You could visualize this like a stack of cannonballs. 1 cannonball on the top, and then 2 squared, 4 cannonballs right underneath it with that 1 cannonball sitting in the right in the middle. Then underneath those 4 cannonballs are 9 cannonballs, so you have this like square pyramid shape of cannonballs. Just like you could visualize the sum of the first n numbers as, here's 1 plus 2 plus 3 plus 4. These are often called the triangular numbers because if I take, say, the sum of the first 4, it forms a triangle with 4 dots, 4 dots, 4 dots, and so on. And sometimes these are called the square pyramidal numbers because we can make a square pyramid of like cannonballs. But there's a formula for this too. N times n plus 1 times 2n plus 1, all divided by 6. And there are formulas for the sum of the first n cubes and formulas for the sum of the first n fourth powers, and so on. This one gave you an intuitive idea how to work it out up here. This one involves a little bit more work.